So up till now, we've been talking about systems with only one solution where they intersect, right? So remember that point of intersection, this is where the solution x comma y is. But there's actually other types of solutions, just like we have with regular one variable equations. Remember when things were true and when things were false? That led us to infinitely many or no solution. So remember, no solution was when we had something false, and infinitely many was when something was true. And this is going to be the same situation with our systems. So in this case, you can visualize it. If it's false, we have what are called parallel lines. Remember, parallel lines have same slopes. And then infinitely many solutions mean the lines are going to be exactly the same thing, meaning they overlap everywhere. So if you think about what that means of overlapping on all the points, if this black or grayish line that's drawn here is the original line, if I was drawing the exact same line on top of it, I'm just basically covering every single point. So every single one of these points overlap, making the infinitely many solutions. Okay? So let's take a look at the example. We can visually see infinite many, one solution and no solution by graphing. And what we can do is always get your y equals mx plus b, just like we've done before, and then graph each line. So if I graph this first line, y equals 3x plus 2, and let's say these are each going by ones on the y and the x. And just like before, I'm going to graph both of them, and let's see what happens. So I'm going to start with line 1, this blue one, at, line 1. My y-intercept's 2. My slope is positive 3, so I'm going to go up 3 over 1. Or I can go backwards and go down 3, left 1. So there's my first line. Then I'm going to go ahead and graph line 2, starting at the y-intercept of negative 1. Slope is 3, so up 3, right 1, up 3, right 1. And you'll see visually these are parallel. So that means there's no solution because they're never going to intersect. Alternatively, if you didn't want to graph this and you can just see this here, you'll see they also have the same slope. So if you see the same slope, different y-intercepts, let me add that in there. So remember how I was making sure you guys wrote same slope, different y-intercepts before? That's why. Same slope, different y-intercept means they're parallel. So without even graphing, we can see that. Okay? Then I can take a look at B. And let's see what happens here. So notice how we have our two equations. Use the same colors again. This time in standard form. So just like we've done in all graphing, right? If it's in standard form, let's make it slope-intercept form. So x minus 3y equals 6. I can subtract the x. And then divide every single thing by negative 3. Negative over negative is a positive, so that's 1/3 x. Oops, let me fix that. My dog just threw a pillow at me, so I got distracted. So 1/3 x minus 2. So I'm going to go ahead and again, let's go by ones. Starting at negative 2 on the y, up 1, 3 to the right, or down 1 and 3 to the left. All right, and then let's try out line 2. So this is 3x minus 9y equals 18. Subtract the 3x from both sides. Then divide every single thing by negative 9. Y equals positive 1/3 x minus 2. And right now we can already see right away they're the exact same equation, which already tells us it's infinitely many. But again, to graph it, you'll see I'm starting on the exact same y-intercept, moving the exact same slope. So these lines are actually the exact same line. So here we're going to say infinitely many. Okay? So if you take a look at the you try, feel free to either graph or solve algebraically. It's up to you. What you'll see here is, again, looking at the equations, exact same lines, infinitely many. Same slope, different y-intercept, parallel. Okay? So go ahead and try those out. One thing you do want to note though is if you do have a situation where you do have one solution, please solve it. So you want to go ahead and either use substitution, elimination, or graphing to solve it. So let's go ahead and check our work. So we had one situation with one solution with number 2. So remember what I just said at the end of those directions. Make sure you solved it so we have that solution. And then for 1, 3, and 4, you'd want to notice we have infinitely many, then no solution, but also be able to explain why. So remember, I'm always asking you guys why, so we want to be prepared to explain it. The one last thing I wanted to show you is sometimes, for example, for me, for number 2, converting both of those in a slope-intercept form to check the slope and y-intercept is an extra step, right? If I had just started eliminating, then I could see, oh, there is a solution. So if you're kind of like me and you don't really want to keep looking at y equals mx plus b, you can also figure out infinitely many and no solution based on the solution that you get with elimination or substitution. And that goes all the way back to what I was saying earlier about what was false and what is true. So let me show you what I'm talking about in terms of solving. So if you didn't want to do this y equals mx plus b for both equations, and you're starting with these two equations all over again, you might think, okay, let's start eliminating. And I might try to eliminate x up here by multiplying it by -2. And that's a great start. And for me, by doing this, if I have one solution, I've already done the work for the elimination. If I have infinitely many, it's going to show up when I start eliminating. So we're going to get -2x minus 2y equals -6. Then 2x plus 2y equals 6 stays on the bottom. And notice what happens. 0, 0, 0. 0 equals 0. This is true, which also leads us to infinitely many. So that's also an option if you'd like to do that rather than solving for y. Go for it. Both of them are very good reasons to explain infinitely many. Okay? Same deal for no solution. So let's just scroll down and look at number 3. Again, if you don't want to deal with just solving for y, here's what you can do. I can take that first equation, y equals -x plus 3, and let's do some substitution here. So 2x plus 2, and I'm going to plug in that -x plus 3 into that equation, equals 4, and this is just like what we did in chapter 1. Distribute, -2x plus 6, and look, when I combine these like terms, they cancel out to 0, and I get something that says 6 equals 4, which is false. And remember, when it's false, it's no solution. So that's, again, an alternative that I personally prefer because I'd rather not do any extra work. If it's going to be one solution, I want to have that elimination or substitution done for me right away. But again, that's my preference, okay? We'll do the word problem when we get back together in class, but please come back with questions on these special solutions. Thanks for listening.